Okay. So keep the angular momentum topic, beta.
Yes.
Angular momentum or it is also called as of your moment of momentum. Moment of momentum. Angular momentum or your moment of your momentum particulation. See, for a particle of mass m, velocity v and momentum particulation, we know that momentum of a particle is given by the formula p bar is equals to m into your v. P bar is equals to m into v. And position vector relative to the origin or any initial frame, we define the angular momentum as L bar is equals to cross product of r bar into your momentum beta. L is equals to r bar cross of your p bar. Or else I can write this one as of your r bar cross m into your v bar. Okay, that means
Yes.
mass will be constant. This will be your r bar cross of your v bar. Direction is given by like cross product beta, a bar cross b bar particulation. So it is something like a bar cross b bar form. So I can write this one as of your m into vr into your sine theta. Then, so this is your angular momentum of a particle moving in a circular path. So L is equals to mvr into your sine theta, where theta is the angle between what beta? Theta is angle between what? R bar and V bar. R bar and your V bar particulation. Okay. If a
Yes, sir.
particle is moving in a circular path of relation, then angular momentum is given by the formula. L is equals to mvr into your sine theta. Like say if this is a particle which is moving in a circular path, and say for example this is your radius of your r, and this particle is moving in a circular path. We are having a particle right now here, and this particle is moving in this direction with a velocity of your v. An angle between them is nothing but equal to your 90 degrees. Okay, so angular momentum is L is
Yes, sir.
equals to mdr into sine theta, and theta is the angle between r bar and as well as of your v bar. If theta is 90 degrees beta, if angle between r and v is 90 degrees, then angular momentum will become for me L is equals to mv into your r, isn't it?
Yes, sir. Yes, sir.
So for a particle which is moving in a circular path, angular momentum is given by the formula mv into r. Can you give me the direction beta? Direction is given by like a bar cross b bar. Here a is r and here it is v. So like assume the r in the outward direction. Take your fingers in the direction of r bar beta. Take your fingers in the direction of your r bar
Sir,
and curl the
upwards,
fingers
sir.
from r to v. The thumb is coming in which direction? Outward direction. Na?
Yes, sir.
Ochinda?
Yes,
Chudo
sir.
ఒకసారి. Take your right hand. Keep all the fingers in the direction of your r and rotate it from your r to v. Rotate it from your r to v. So thumb is pointing in which direction? Outward direction.
Yes, sir.
So L bar is outwards. వచ్చిందా డైరెక్షన్ ఒకసారి చూసుకో, రాకపోతే ఐ విల్ టెల్ యూ వన్స్ అగైన్. డైరెక్షన్ ఆర్
Sir,
బార్
all
క్రాస్
fingers means,
ఏనా?
so we have to put all fingers in direction of R, or only our thumb, and then you have to curl it.
No. What you do is stretch your hand totally better and such that thumb is perpendicular to the forefinger.
Okay, yes, sir.
Okay, now keep all the fingers, only fingers, forefinger to your tip finger, index, what do you call that, small finger. Keep all the four fingers in
Yes,
direction of R and rotate from R to V.
yes, sir.
The extended thumb is coming in which direction? Thumb in direction of
Outwards,
what?
sir, upwards.
Upwards kada. అవునా కదా? If your laptop
Yes,
or
sir.
if your system is in the on the table, it will be upward. If it is vertical to you, it
Yes,
will
sir.
be outward.
Yes, sir.
అవునా కదా? So that means angular momentum is outward. Angular momentum is outward. ఒకవేళ velocity కింద ఉంటే, velocity of the particle if it is in the downward direction of angular momentum, take the
Inwards, sir.
fingers inwards particulation. I hope you got an idea.
Yes, sir.
Chalo. The same way, if I am talking about angular momentum of your purely rotating body,
Sir, once can you show the previous? Okay.
Next one. Angular momentum. Angular momentum of a rigid body. Of a rigid body or purely rotating body or purely rotating body. Okay, so we are talking about right now of angular momentum of a rigid body or a purely rotating body or purely rotating body. Like if a particle is rotating in a circular path like this, and this is your radius of the particle, that is nothing but of your r, and velocity of this particle, here is right now your particle of mass m, and here it is moving with a velocity of your v. Okay, and the center of this one is nothing but of your o. The body is rotating like this, so angular velocity of this one is nothing but in this direction. So consider a particle of mass m moving in a circle of radius r, and at some instant the speed of the particle is say v. So let origin of the particle will be at the center beta, that is nothing but o. So how do you write the angular momentum for this one? Angular momentum is L bar is equals to r bar cross of your p bar. Antena. So what is L beta? L is equals to always along what? Axis of your circle. It is along the axis of rotation. Angular momentum is along the what? Axis of your rotation. Is the axis of rotation kada?
Yes, sir.
So this is your active. Angular momentum is along the axis of your rotation part of relation. Along the axis of your rotation of your particle part of relation. Okay, na? Like say for example, if I'm talking for your given condition right now, L is equals to R into V. So this can be written as of your L is equals to your, this one is your R. P can be written as of your M into your V. We know that in circular motion, a particle is moving in a circular motion. V is equals to R omega kada. So this will be equal to
Yes,
your
sir.
M into V value. I'm writing it as R omega into this value of your R. So this will become for me how much? M into R square into omega na beta.
Yes,
So
sir.
see this one carefully. L is equals to M into R square is what beta? M into R square is moment of inertia.
Yes, sir.
I into omega. So angular momentum for a rigid body is how much beta? L is equals to I into your omega. L is equals to your I into your omega part of relation. Okay, na?
Yes, sir.
Okay. So for a rigid body, this is the formula. For a particle, if I am writing for a particle, what is angular momentum beta? L is equals to mv into your r. In terms of your velocity, will be writing. So for any particle, if I am writing the relation, L is equals to your mv into your r. For two particles, if I am writing, if initial angular momentum is equals to final angular momentum, and this can be written as of your m1 v1 into your r1 is equals to your m2 v2 into your r2. Okay, na? So
Yes,
depending
sir.
upon the knowledge, we can given the relations part of relation. If you need to calculate V1 or V2, you can calculate from the given conditions. Okay. So angular momentum is given by the formula L is equals to mv into r for a particle. For a rigid body, L is equals to your I into your omega part of a relation. Okay. Na? So keep a small note here right now. Very important. See here. The net force acting on the particle right now. If I'm writing the angular momentum like this, see like L bar is equals to R bar cross of your M into your V bar. Okay. If I differentiate this one with respect to time, what do you do is differentiate with respect to time. With respect to time. That is dl divided by your dt. dl divided by dt. So that is equals to I can differentiate this one. So it is dr divided by your dt. So the next one is nothing but equal to your into m into your v part of relation. Then in this one, keep the mass of this one, the radius of this one to be constant. Mass is also constant. So this will be equal to your plus r bar into your, this is nothing but of your m into dv by your dt. Product rule beta, differentiation. Keep the second term constant, differentiate the first term. And the second term mass is a constant, r and m are the constant, and velocity is a differentiable. So it is dv by your dt part of relation. Now tell me this one, dr by dt gives me what beta? Velocity kada. So this one is your velocity,
Yes, sir.
your m into your v bar, plus this one is nothing
V
but equal
square.
to your r bar into your m into dv by dt gives me what beta? Acceleration. So this is your acceleration. Now see, v bar cross v bar ఏమవుతుందన్న? A bar cross A bar is how much? A bar cross A
Zero,
bar is
sir.
how much? 0. So V bar cross V bar will become how much for me? 0.
Zero, sir.
So that is equals to your R bar cross M into your A is nothing but what? Force kada.
Yes,
So I
sir.
can write dl by dt is equals to, I can write dl by your dt is equals to your R bar cross F bar. What is R bar cross F bar beta? Torque.
Yes, sir.
dl by dt will be equal to torque. So this is one of the relation again between the torque and angular momentum. So dl by dt is equals to your torque. That means rate of change of angular momentum. I can write the definition here right now. Rate of rate of change of rate of change of angular momentum. Rate of change of angular momentum of a particle is equal to what beta? Torque is equal to the torque of the net force acting on it.
Yes.
Net force acting on it. అంతే కదా, anything divided by time is rate. So rate of change of angular momentum is also called as of your torque part of relation. This is exactly similar to like it is similar to it is similar to Newton's second law అన్న. What is the Newton's second law? So dl by dt బదులు ఏం చేస్తాం మనం? L బదులు momentum రాసుకోవచ్చు. This is dp bar by your dt bar will be equal to torque బదులు force రాసుకోవచ్చు. It is your force. Newton's second law ఇదే కదా. Rate of change of your
Yes,
linear
sir.
momentum is nothing but of your force. Rate of change of linear momentum of the particle is equals to your force. Whatever is the role played by the force in Newton's law, the same role is here is played by what? Torque in the rotational mechanics part of relation. Okay na?
Yes, sir.
So that is about your angular momentum of your particle part of relation. So I hope you got a rough idea related to this one. How do you calculate the angular momentum of the given condition? Okay na? Chalo. Next one is
Yes, sir.
relation between between relation between angular momentum, relation between your angular momentum and rotational kinetic energy and rotational kinetic energy. Rotational kinetic energy. Tell me what exactly is first kinetic energy of your linear particle beta. So if I'm talking about your kinetic energy of your particle, Chapu, kinetic energy of your particle will be equal to how much beta? Half into m into v
And
square kada.
yes,
Avuna
sir.
kada. So for a particle we know v is equals to r omega if it is rotating. So it is half into m. V is equals to r into your omega whole square. So that will be equal to how much for me? Half into m into this one is r square into omega square. M into r square is what beta? I kada. So this one is your half into I into your omega square. So
Omega.
this will be your kinetic energy. So kinetic energy will be equal to your kinetic energy will be equal to how much for me? Half into I into your omega square. Avuna kada.
Yes, sir.
So kinetic energy is that one. So I know that relation right now as angular momentum L is equal to how much beta? I into omega. So from this one, can I write omega is equals to your L by I and raskocha? Substitute
Yes,
this
sir.
value in kinetic energy. If I substitute that value in the kinetic energy, so
I
this
and
will
I
come
also
out
will
for
get.
me. Kinetic energy is equals to half into m. Omega is equals to how much for me? L square by over I square.
Sir, but one I will get cancelled.
This is m kaadu I kada. Sorry.
Yes, sir.
So this one is your I here. Sorry. So this one is your I, and this one is your L square divided by your I square. This L
Now
and
one
this square
I.
will get cancelled. So kinetic energy will become how much right now, beta? Kinetic energy will be equal to your L square divided by 2 into your I. Okay, na?
Sir, once can you show the previous picture?
Yeah. So kinetic energy is half into I into omega square part of relation. So omega
Yes,
is
sir.
equals to how much? L into I. You substitute value here. So kinetic energy is equals to half into I into, if I'm substituting the place of omega, L square by I square. So simplified, you are getting kinetic energy is equals to L square by 2 into your I. It is similar to, it is similar to, in work for energy we have written, kinetic energy is also equal to your P square divided by 2 into your M. అవునా కదా? See how we
Yes,
got
sir.
this one. Kinetic energy is equals to half into m into v square kada. Divide and multiply by your mass. So this will become for me how much? M into m. This will become for me m square v square divided by 2 into your m. M into v is what? Momentum hai kada. So this one is p square divided by 2m. Isn't it? So in rotational mechanics,
Yes, sir.
kinetic energy is L square by 2I. Whatever is the role played by angular momentum in the rotatory motion, the same role is played by the linear momentum in the Newton's laws. Whatever the role is played by mass in the Newton's laws of motion, the same role is played by the moment of inertia in the rotational mechanics part of relation. So that is the relation between the kinetic energy and as well as of your angular momentum. So this is your formula which you need to remember. Kinetic energy is equals to, kinetic energy is equals to how much for me? L square divided by 2 into your I part of relation. And kinetic energy of a particle is how much beta? Half into I into your omega square part of relation. Clear?
Yes, sir.
Isn't it?
Yes, sir.
How do we calculate the angular momentum of your any particle part of relation? Okay. So in Newton's second law, what is the Newton's second law right now, beta? Newton's second law says that for me, tau is equals to your force is equals to dp by dt. So this one is also called as of your Newton's second law, beta. This one is also called as of what? Newton's second law. Newton's second law. అంతే కదా? Rate of change of angular
Yes.
momentum. Rate of change of momentum is force. Rate of change of angular momentum is equals to your torque of your given body part of relation. Okay, na?
Yes,
Sure.
sir.
Next one is conservation of angular momentum. Conservation of angular momentum. What do you mean by conservation, beta? Conservation. Conserve అవ్వడం అంటే ఏంటి? No change.
Same.
Initial ఎంత అయితే
Yes, sir.
ఉంటుందో ఫైనల్ కూడా అంతే ఉండాలి. Like
Same.
momentum is said to be
Without any
conservative.
changes.
Initial momentum must be equal to final momentum part of relation. So for the conservation of your angular momentum part of relation, the net force acting on your system must be equal to your zero. The net force acting on the system must be equal to zero part of relation. Now see here, as we know that, as we know that angular momentum L bar is equals to your dl by your dt. dl divided by your dt part of relation. If net torque acting on the system is zero, if tau net acting on the system is equals to zero, if the tau zero అయిందనుకో then ఏమైపోతుందన్న? So then dl by dt will be equal to zero. Differentiation of this one zero అవుతుందంటే L bar will become how much for me? Constant కదా. L bar is equals to constant. అంతే కదా. Differentiation of any constant is only zero. If
Yes, sir.
angular momentum
Yes,
is
sir.
equals to constant, then only this value is equals to zero. That means when
Zero.
net
Yes, sir.
external torque acting on a system is zero, the total angular momentum of the system is constant. So I can write the definition here right now. When the net external torque, when the net external torque acting on a system is zero, acting on a system is zero, then the total angular momentum, then the total angular momentum, then total angular momentum of the system is constant, So when the net external torque acting on the system is zero, then total angular momentum of the system is constant. Make sure that while conserving the momentum particulation, right here, while conserving angular momentum, while conserving angular momentum, keep this point in the first condition beta. First make sure that the external torque is zero or negligible, okay. And second one is before and after the angular momentum about the axis, take the angular momentum about the same axis, okay na? So whenever you are conserving the
Yes.
momentum, so when the momentum is said to be conserved beta, if net external torque acting on the system is zero, then angular momentum is conserved. Then what do you need to do? Before and after the angular momentum, take the angular momentum about what? Only the axis of your rotation. Take the angular momentum only about the axis of your rotation particulation. So, look, example is one.
Yes.
Let me give you one example.
Sir,
If,
once can you show the previous?
yeah. So what is an angular momentum?
Okay, sir.
When net external torque acting on system, when net external torque acting on a system is zero, then total angular momentum of the system is said to be what? Constant. So angular momentum is equals to your constant.
Yes.
Angular momentum is equals to constant and L is equals to constant. That means L is what beta? I into omega is equals to constant kada? And I can write
Yes.
I1 omega 1 is equals to your I2 into your omega. అవునా కదా?
Yes, sir.
Angular momentum is constant ante I into omega is constant, or I1 omega 1 is equals to your I2 into your omega 2 particulation. See the question here, see. If radius of the earth is doubled, without change in its mass, what will be the length of the day? What will be the length of the day? చెప్తావా? చూడు, what is the given condition? Radius of the earth is double, అంటే ఇది ఎర్త్ అనుకుందాం, అవునా కదా? దీని రేడియస్ r,
Yes, sir.
దీని మాస్ m. దీన్ని నువ్వు డబుల్ చేస్తున్నావు. ఇప్పుడు మనం డబుల్ చేయగలుగుతామా? ఇది చేయలేం కదా, అవునా కదా?
Yes,
What
sir.
it is a process, internal process kada. Internal some reaction వల్లనే
Yes, sir.
maybe the molecules might be expanding and the earth might be expand. Mass is remaining same.
Yes, sir.
అంటే there is no external force acting on the particle. So when there is no external force అంటే there is no external torque, isn't it? As there is no external torque. No external torque. ఏమైనా టార్క్ అప్లై చేయగలుగుతున్నావు నువ్వు దీనిపైన? ఈ ఎర్త్ పైన ఏమైనా ఫోర్స్
No,
అప్లై
sir.
చేయగలుగుతావా టు ఎక్స్పాండ్ ఇట్? నో కదా. సో there is no external
No, sir.
torque, that means torque is equals to 0. Angular momentum is conserved కదా. L is equals to what for me?
Yes, sir.
Constant. So it is I1
It
omega
remains.
1 will be equal to your I2 into your omega 2. It is like a solid sphere kada. Earth is like a solid sphere.
Yes, sir.
So for solid sphere, what is the moment of inertia? I told you 2 by 5 mr square.
Yes, sir.
For solid sphere, the moment of inertia is 2 by 5 mr square. Remember, for solid sphere, for your solid sphere, it is 2 by 5 m into your r square. For hollow sphere,
Yes, sir.
moment of inertia for your hollow sphere, ఇది as it is గుర్తుపెట్టుకోవాల్సిందేనా, that is 2 by
Yes,
3
sir.
m into your r square. Okay, now
Yes, sir.
now see here, I1 omega 1 is equals to I2 omega 2 ante first one is nothing but 2 by 5 into this is nothing but m, initial is r square into angular velocity is omega. Next one is 2 by 5, mass is remaining same but radius is double, that is nothing but 2r square into omega 2, that is nothing but omega dash. This 2 by 5, this 2 by 5 gets cancelled, this r square and this r will get cancelled, so 2 square is nothing but 4. So what I can write here, omega dash beta, omega dash will be equal to your omega by 4. Can I write like this?
Yes, sir.
Isn't it? So that is the way how do we are conserving the angular momentum of your particle relation. Then again in the what will be the length of the day? What will be the length of your day particle relation? How do you calculate the length of the day beta? We know that omega is equals to as omega is equals to 2 pi by your capital T. T will give me what time period of the earth kada. So what is the time period of the earth's rotation beta? 24 hours.
Yes, sir.
T is equals to your time period of your earth. Time period of your earth. What is the time period of the earth? That is 24 hours. One complete rotation is nothing but how much? 24 hours.
24 hours. Yes, sir.
Angular momentum is omega dash is equals to 2 pi by your T dash. We need to calculate this new time period. So we already know omega dash is equals to omega by your enta 4 kada. Omega dash is
Yes,
2
sir.
pi by your T dash. This is equals to 2 pi by your capital T into your 4. This 2 pi will get cancelled. So T dash is equals to how much I'm getting beta? T dash is equals to your
24 into
identa దేని రాశాను T, yeah. So T dash is equals to T into your 4. Antena?
that is 24.
So yeah, time period is how much? 24. 24 into 4. Enta?
96.
So new time period will be 96 hours. Ante ఒకవేళ radius of earth గనక double అయిపోతే then your one day will be equal to how much? 96 hours.
96 hours.
వచ్చిందా? What an idea.
Yes, sir.
Isn't it? That is really very important for the given conditions particle relation. So this is the way how do we calculate the angular momentum of your particle relation. Okay, na?
Yes, sir.
Got an idea how to calculate the time period of this one?
Yes, sir.
Okay. Very good.
Sir, again, actually, the remaining meeting time, a warning వచ్చింది సార్ మళ్ళీ.
బా మళ్ళీ వచ్చింది అది 1-2 days కోసం ఉండేనేమో.
Yes, sir. అంటే it is up till 7:30, sir. Correct 7:30.
కరెక్ట్ 7:30 వరకు ఉందా?
Yes, sir.
So that is the way how do we calculate the angular momentum particle relation. I hope you got rough idea beta.
Yes, sir.
Let us try to take one more question faster way. Say for example, a heavy circular disc, a heavy circular disc of mass capital M, of mass capital M is revolving in a horizontal plane, is revolving in a horizontal plane with angular speed omega naught, with angular speed omega naught about its center fixed. ఇది మంచి పెద్ద టాపిక్ నాన్న ఇది. సో ప్రాబ్లమ్స్ మంచి పెద్ద పెద్ద ప్రాబ్లమ్స్
Yes.
ఉంటాయి దీంట్లో. కాన్సన్ట్రేట్ a lot actually. An insect of mass m, you try to read the angular momentum today itself from your material beta once. Okay, an insect of
Okay.
mass m walks from the center to the edge and then flies away. Find the final angular speed. Find the final angular speed of disk. Okay,
Yes.
so read the question first. We got a heavy circular disk. This is your heavy circular disk first. This is your heavy circular disk. This is your other situation of your disk. Okay, so this is a heavy circular disk of your mass of your how much beta m. The mass of this one is equal to your m. This is the center right now of O. Mass of this one is of your capital M, and some insect is here right now at the center. Okay, mass of the insect is how much? Small m. Ante kada, a heavy circular disk right now for the given condition of mass capital M is revolving in a horizontal plane with angular speed of omega naught. Like say angular velocity of this one is omega naught. Okay, about its center, an insect of mass m walks from this center to the edge. Now this insect is walking from this one, and the insect comes here right now somewhere at this position, isn't it? This is your mass m. So when it is been moving like this, the angular speed of this one is changing to your omega. An insect of mass m
Yes,
walks
sir.
from the center to the edge and then flies away. Then find the angular speed of the disk. Final angular speed is equals to omega anukundam, isn't it? Is there any external force acting
Yes.
on the insect to move kada? No kada kada. No external
No,
force
sir.
is there.
Only.
So yeah, so angular momentum is conserved. So I can apply by conservation of by conservation of angular momentum, by conservation of your angular momentum about point O, about your O. So I can write here I1 omega 1 will be equal to your I2 into your omega 2. Be careful here beta. What is the moment of inertia of the disk when the mass is exactly at the center? Moment of inertia of this one is about in center and perpendicular to the plane. So what is the moment of inertia of the disk? Mr square divided by 2. Avuna kada? Initial angular
Yes.
velocity is omega naught. I2 will be equal to how much right now? Moment of inertia of this one is somewhere here. Idi axis kada. Avuna kada? And this is already
Yes,
center.
sir.
I already told you the parallel axis theorem kada. Cheppana parallel
Yes,
axis
sir.
theorem.
Yes, sir. Check.
Two axes are parallel kabatti I2 will become for me ICM plus of your mass of that particle small m into your r square into your omega 2 is nothing but omega. So this will become how much for me? M into your r square by 2 into your omega naught is equals to moment of inertia of the disk will be equal to how much about the center? Mr square by 2 plus this one is m into your small r m into your r square into your omega part of relation. ఏదైనా కట్ అవుతున్నట్లు కనిపిస్తుందన్నా నీకు? సో ఈ ఆర్ స్క్వేర్
MR square M
ఈ
square by.
ఆర్ స్క్వేర్ విల్ గెట్ క్యాన్సర్, అవునా కదా? సో
Yes,
దిస్
sir.
విల్ బికమ్ ఫర్ మీ హౌ మచ్? m by 2 into your omega naught is equals to this one is also your m by
M
2
by
plus
2.
of your small m into your omega, అవునా?
Yes.
So omega
Yes,
will
sir.
be equal to how much? Omega will be equal to your, this one is nothing but of your omega if I am taking right now this one. So if I keep this omega as it is, this one is your m by 2 into your omega naught divided by this one is your m by 2 plus of your small m, అవునా కదా? దీన్ని ఇంకా సింప్లిఫై చేసుకోవచ్చా? ఈ 2 తీసేస్తే ఇక్కడ 2
Yes,
తో
sir.
మల్టిప్లై
Check.
చేసుకోండి, అవునా కదా?
Yes, sir.
So omega will become for me m into your omega naught divided by divided by, this will become for me capital M plus of your 2 times of your small m, right sir? So
Yes.
this is the
Yes.
new angular velocity. I hope you got an idea.
Yes, sir.
Okay, so what is the new angular velocity when it is been flying off ante omega is equals to m into omega naught plus capital M plus of a 2m. ikkada I2 kada manamu center of what we call the parallax theorem we are applying. You be little bit careful of that one beta, because when the total system is at the center, moment of inertia is how much for me? mr square by 2. Moment of inertia for small m will become how much beta? 0, because it is passing through the axis kabatti. Avuna kada. Now for the
Yes,
next
sir.
one, the particle is at a distance of your r from the axis of rotation. So moment of inertia, these two axes are parallel. Kabatti I is equals to ICM plus of your m into your r square. That is the reason I have taken I2 is equals to ICM plus of your small m into your r square. Moment of inertia of the disk passing through center and perpendicular to the plane is how much? mr square by your 2. Okay, na? To simplify it, you will get the answer for the given question. Clear?
Yes, sir.
So this is your about your introduction about your angular momentum and conservation beta. We'll try to do the numericals based on this one in the tomorrow session of a class. What is the date today? 22 kada?
Okay. Yes, sir.
22 12 2020. కెమిస్ట్రీ ఎన్ని మార్క్స్ వచ్చాయి నీకు?
Sir, chemistry lo I got 120.